There's quite a few of us here already, so I'd like to welcome everyone, wherever you are, to yet another Codacy webinar. And today we want to approach the topic you see on the screen. So how to make the most out of static code analysis. My name is Eloisa. I'll introduce the session very briefly and then moderate the Q&A later. So before we begin, hopefully we're gonna share a few interesting tips with you today on how to make the most out of whatever you're using for static code analysis, some advanced tips for those who already are familiar with it. And first things first, the session is recorded, as you've noticed, so even if you miss any part of it or want to revisit it later, it's fine. You're gonna receive a recording from us. Second thing is, how can you in the audience participate today in the discussion? We are always going to keep the chat open, so you have a chat button down here at the bottom. Feel free to introduce yourselves. And we also have a Q&A button down here that you can use to ask us any question that comes up during this webinar. Because at the end of the session, we'll save a few minutes for our speakers to answer some of your questions. And speaking of speakers, we have here with me Dave Liddament, who's a director and a developer at Lamp Bristol. Lamp Bristol is a software company that builds software that builds successful startups. And I'll let them introduce themselves a little bit better in a bit. But yeah, Dave is also known as a PHP expert and someone who's very excited to share his knowledge on static analysis and the PHP language. With me also here today is the VP of Technology at Codacy, Kendrick, with so many years of experience in managing engineering teams and all of the struggles that those teams face daily. Also, his experience in software development has been in PHP and other languages. So, but I'll let them introduce themselves in a bit. Just one last thing is, if you do ask us a question in the Q&A, I'll know who you are, and I'm gonna get in touch with you to offer you a nice Codacy swag box. So that's another incentive. But without further ado, let's get it started. So I'd like to hear from you, Dave.
Hi.
Go ahead.
Thank you for having me on your webinar. So I'm Dave. I work for Lamp Bristol. As you said, we build software for startups, and I've been doing software development for many languages for, it seems, many years now. And I've used static analysis quite a lot because it helps me make fewer mistakes in the code and makes the code that we build more robust. And that's particularly important because a lot of our projects are quite long running. We've had some that are going for 12 years, some that's 8 years, and some that's 5 years. So those are the projects that we've been working on now for some time. And we've definitely found that some of the things I'm talking about in this webinar will help me. So hopefully they'll help the people watching.
Brilliant. Maybe we can go to the agenda and see what we can expect today. Can you tell us a bit more about what we're going to talk about?
Sure. So we're going to look very briefly why I believe static analysis is so important and how it can help us. We'll also look at how we can use static analysis to extend, in this case, the PHP language. So we have more functionality than the PHP language gives us. And these concepts, although we're talking about PHP, will probably transcend languages. And we'll briefly look at also how this maybe change in the way you code things to take full advantage of static analysis. And I think at the end of that, we might have some time for some Q&A.
All right, thank you. What about you, Kendrick? Can you hear us okay?
Yeah, I'm good. Sorry, I had myself on mute even. Hi, I'm Kendrick. I'm VP of Technology at Codacy. I'm sure you saw me 2 weeks ago on the Codacy product showcase, but I've been in software for 20 years as a developer and Scrum Master, and latterly manager and leader. Dave and I worked together many years ago, on some PHP applications at a software house. So I'm very, very happy to bring him back to us to tell us about cool static analysis stuff. So I guess, Dave, how did you get into static analysis in the first place? Was it due to how PHP was at least 15 years ago, with lots of missing features, very flexible language that's easy to do lots of really bad stuff with?
Yeah, so I mean, as well as PHP, I've used many other languages, and I liked features from all of the languages. For example, languages like Java give a lot more type safety, or certainly gave you a lot more type safety than PHP did. And PHP has evolved quite a lot since that project we worked on, whatever it was, 15, 16 years ago. But I found to get the most out of PHP, static analysis tools have helped. So specifically, the kind of tools that I'm talking about are tools like PHP Stan and SARM and PHP. Both of those tools do some quite advanced analysis. And what that can do is improve your type safety, so alert you to a whole range of issues that you might not be aware of otherwise. And it can also emulate some of the languages that some of the features you get and some of the benefits you get from other languages, while still having all the benefits of PHP in terms of, you can make changes and you don't have that compilation stage. You can just see, your changes almost instantly. So yeah, it's because I've worked in many other languages and I see the benefits of bringing those kind of things via static analysis into PHP.
Okay, so pretty much every language has got at least one linter. I know PHP has 4. But why do you think static analysis is so important for languages to have?
It's really important because it can help us find issues and bugs sooner. So like a very simple example is, if we've got this code on the screen, if we call the update method on our instance of person, if we ran this code, this would fail. You would get an error thrown saying you can't access private method. But the benefit of static analysis is we don't even need to run this code. The static analysis tool can look at it and it can tell us that we have made a mistake. So, and sometimes you get that benefit in your IDE as well, and IDE often has got a lot of static analysis as part of it. So what this means is we don't have to wait till a bug gets out into the wild for us to find it. We can run static analysis on our code and it will point out the issues. So this, I suppose, is quite an obvious bug. The next one is a bit more of a subtle bug. We've got this find person function. You give it an email and it returns the person if one exists, otherwise null. And we've got this process function, which takes a person. And then the code, which is potentially problematic, is we have $person, we're looking up Jane at example.com, and then we're calling whatever, we're passing on whatever we get from that to the process method. And the issue here is what we get back from find person. It could be a person object or it could be null. And the process method or process function only takes a person object. So static analysis will look at this and say, well, there is a potential bug in here. You can have essentially a null value bug in here, which might not be obvious when you're reading the code, and you might even have some level of testing, but it doesn't pick this up. So I think this is why static analysis is so important, because it finds bugs even prior to testing and certainly before your code gets out into production.
Okay, but with yeah, and that's helpful, but surely both this and in the previous example as well, then if you've written some good tests, then your unit tests will pick up on some of this stuff, right?
I mean, that is true. So you still need tests. I think you need both tests and static analysis. The tests are the only way that we can actually check the behavior of the system is correct. And static analysis on the whole finds issues with your bugs or potential issues. So if we look at this code here, we've got a function that's calculating the cost. If it's an adult, it returns 10, and a child, it returns 5. So we could write tests, and indeed we should write tests. So we would have one test where you give it adult and it expects 10, and you'd write another test where you pass in child and it would expect 5. And if we ran those two tests, all the tests would pass. and every line of code would have been executed. So if we were looking at line coverage, we would say that we've completely covered this function. And this is a deliberately simple example. Real code is a lot more complicated, and but we're just doing some simple examples so we can kind of all understand it. And the issue we have with this code is, well, what happens if you call cost with a string that isn't adult or child? In this case, the code would fail. And there's a few ways around this. First of all, probably with PHP 8, we could start thinking about using enum type. So we could have an enum with the adult and child. And then our cost function becomes a bit simpler. We just call a match statement, and the functionality is the same. Now, it does have this extra bit now, the defaults clause. So if in the future we added something to the type enum that wasn't adult or child, then what would happen here is an exception would be thrown, and we'd have a bit of additional information, like what was the type passed in. But actually, that is still, in essence, the same problem as before, in that the only way you'll know about this code is if you have a test for it, or if it goes out into the wild. So I'd actually advocate, now static analysis world, we remove the default clause from our match statements. So our code looks more like this. And then if we added a new type to the enum type, for example, student, and we pointed our static analyzer, PHP stan, at this code, it would tell us immediately that we are missing something from match. It would tell us that we haven't accounted for the case students. And don't forget, our tests would have 100% coverage of all of this anyway. So even if we went and added the new student type, and we said, right, I'll look at my code coverage to show me where I might need to add new code, it wouldn't help in this case. So it's only static analysis that can help us find these kind of issues. And I think that is why you need static analysis as well as tests.
Yeah, I mean, and enums are nice, and lots of languages have similar constructs to them as well, right? But there's plenty of legacy applications out there in JavaScript, PHP, and Python where you might not be able to graft on an enum type or refactor everything. One of the common problems with the refactoring is that actually you don't have any unit tests because your code is not good enough, it is not well laid out enough to be able to write unit tests, right? So, what if you can't use enums? Do it with one hand behind your back.
Well, this is the other thing. So as well as tools like PHP stan, understanding everything in the PHP language and warning you of issues like that, another benefit is it can extend the language. So this example here, we're back to our original codes, and we've added a dot block, the bit in purple. And what this means here is that $type isn't just any old string. It can only be the string adult or the string child. So again, we're saying cost can only cope with these two strings. And our tool like PHP stan will go and look at all the places in the code base where the function cost is called. And if at any point you're calling it with something that isn't adult or isn't child, then it will say, hang on a minute, you're calling cost with something that cost isn't expecting. So again, this is, as the previous example, static analysis can help us find kind of issues. I mean, when this code was written, there probably really was only adult and child, but at some point in the future, someone adds another type in. And the ability to have these additional type information here, for example, like the fact we can say that $type isn't just any old string, it's either adult or child, is quite powerful. And it's these kind of extensions of the type system that tools like PHP stan bring. And there are many other examples like this, but this helps us certainly when we've got legacy code where maybe we can't use the latest language features.
Yeah, so I come from a CRUD, like database app development sort of background. I look at this and I see a data item there, $type, and I think, well, actually that value is going to get filled in from a database somewhere, right? So the string adult or child is not going to be fixed somewhere else in your code base, ready to be pumped in here. So what do you do about situations like that where the data that is coming in from somewhere outside?
Yeah, you'll always have a boundary with the code you're writing and some external system. So whether it's a web interface, command line interface, or in your example, a database. And the database will probably only be dealing with strings. So there's a couple of things you would do is you would probably, first of all, have some kind of assertion that the data you're pulling out of the database is only of type adult or child. And the other thing you do is, let's say you're putting that data into an object with a get method to get whatever the type is from the database. On that get method, you could do something similar to what we've got in purple, but it'd be at return, and then it'd be adult pipe child. So what that would do is where we have the boundary with the other system, we're kind of asserting that the data we get in the database is an expected value. And then we are telling static analysis through the dot block, the at return dot block in this case, that this string is only adult or child. And then the rest of the analysis will go based on the fact that our database value is one of those two types. So yeah, you've got to kind of put a boundary around your code, and anything that's outside of that boundary, you've got to either validate or assert that it is a value you're expecting. And once you do that, all the rest of it, within that boundary, everything's fine because static analysis knows what's going on.
Yeah. Yes. Once you got into the boundary, having a get, annotating your get is probably the smart way to do it.
Yeah.
Can you maybe tell us a little bit about how static analysis tools work in general, because it's not a compiler.
Yeah.
Although these pretty much every language has a compiler at one stage or another, but static analysis isn't actually compiling the code, is it? What is it doing?
Yeah, well, actually, there's one more example before we move on about extending the type system, if I may. We've got also one thing that's quite powerful that comes to that static analysis offers us is an extension to the type system called generics. So PHP's type system has improved a lot since the days we were working on it together. But what you cannot do yet in code like this is, suppose we have a function called getPeople. We can say that it returns an array but we can't say at a language level what the contents of that array is. So if we have code like this, we've got the welcome method, which is suspect person, and you can see people, we get the people, and we iterate through the people, and we pass that to the person, to the welcome function. Now, this may work, this may not, but what we can do is we can give our static analysis tool extra information, again via a dot block, so we can do at return array and then the angle brackets person. And what this allows us to do is our static analysis tools know, therefore, that whatever you get from getPeople, the value in the array of each item in the array is of type person. And it will also look at the getPeople function and make sure that the array it returns contains only person objects. So this is just the start of something called generics, which is something that PHP doesn't have yet, and potentially, due to the way the language is, potentially never will. But with static analysis, we can give it this powerful feature. So I just wanted to show you that. But coming back to your question about how do static analyzers work, so for tools like when we run code, this is what happens in PHP, but it's similar to what will happen in many languages. So you start off on the left with your actual code. It goes through a tokenizer phase, so that's to break the code up into chunks, and those are converted into something called the abstract syntax tree. And this is probably similar for nearly all languages. In PHP world, the abstract syntax tree is then converted into a series of opcodes, which are then run on a virtual machine. Other languages will have a few other bits after the red box. Now, the bit we're interested in terms of the kind of static analysis that I'm talking about, is the abstract syntax tree. And it is a structure with lots of different types of nodes, and the nodes all linked together. And you can take any code in PHP and represent it in an abstract syntax tree. And again, as I say, this is generic to many, many languages. So for example, this bit of code, we've got a class which is kind of the red blob at the top, so the class node, and it's got an identifier to the left in blue, which says the name of this class is person identifier, and we can see it's got properties and it's got methods, and you could drill down into the methods as well, and you can see it's got names and so on and so forth. So the point is, you can take any code, any PHP code, and represent it in something that in reality will be a lot more complicated than that. And this is quite powerful. So how static analysis tools like PHP Stan work is they iterate through the entire abstract syntax tree, and so for example, if you start up at the top, it says, okay, I'm looking at a node that's a class, and there will be several rules that will all say, I'm interested in nodes that are of type class, and they will do some analysis on it and potentially report problems. And then once it's gone through the node and found all the rules that are interested in class, nodes of type class, it will move on to the next node and the next node and the next node until it's gone through the entire code base. So what that means is we can make use of all of the rules that PHP Stan offers us, but we can create our own custom rules. So I'm going to show you an example here. And this is probably an example where you've got similar things in your code base. So I have a process, I want to send text messages, and relatively sending a text message is very slow. It's got to do an HTTP request, maybe that will fail, maybe it'll be slow. So I don't want my normal code to call a text message sender directly, so I don't want my code in blue to do this. Instead, what I will do is I will say, I'll put something on a queue to say, I want you to send a text message. And it is only the text message queue processor, the yellow box, which is allowed to talk to the text message sender, which is allowed to call anything on text message sender. And this is a convention I have in Codebase, and I want to make sure that I don't forget it, or other developers who may not be aware of it also don't forget it. So what we can do is we can create our own custom rule that enforces this and is run along with all the other rules that PHP Stan runs. And then we've got this extra checker that is specific to our code base. So we're going to see now how we can write a rule similar to this. So if we think about the code, what we're kind of saying is we've got this sender, send message, and we're saying if the $this sender refers to a text message sender, then it can only be called from within the text message queue processor class. So this is what the rule that we're trying to make does. So thinking about the abstract syntax tree, the construct this sender send message is a node of a type of node called a method call. And a method call has got three properties. It's got the variable that it's calling it on, it's got the name of the method that's being called, and it's got any arguments that are being passed to it. So that's kind of like the blue, the green, and the yellow in this diagram. So we know we're interested in a method call, and we're going to do some analysis based on that. So a PHP Stan rule is an implementation of this interface. So there's two methods you need to provide an implementation of. The first is get node type, and the second is you process the node and you get the node and you get some additional thing called the scope, and you return an array, and the array has the number of errors. So if there are no errors, it will return an empty array, or if it finds an error, it can return one or more errors. So let's create our class. So we've got our text message sender caller rule. Potentially there's a better name than that. And what we're interested in is our get node type, where, as we saw earlier, the type of node we're interested in is called method call. So we're saying I am interested in method calls. And this means that every time PHP Stan comes across a node in the code base that is of type method call, this rule will get called. Specifically, the process node method will get called. So first question we are going to ask is, in our process node thing, we're going to find out what class we were in when we made this method call. So we've got the calling class, and scope is provided for us by PHP Stan. And what scope does is it gives us additional information as to where we are within the code that we're being analyzed. So here we're saying, get me the name of the class that we are in when we're at this node, when we're at this method call in our code base. And so if we imagine we've got some code that looks like this, we've got this message sender towards the bottom of the slide, and we can see that it is in a class called person notifier. So we can say that $this sender is called from person notifier. So if you look at the first line in this method, we're asking where we are, and so in this particular case, calling class will say I'm in person notifier. And then the next thing that happens is to say if the calling class is in text message queue processor, we're going to return an empty array. And the reason we do that is, remember what we're saying is we are allowed to call text message sender from text message queue processor, and we're not allowed to call text message sender from anywhere else. So if we're in a class, which is text message queue processor, and we've got a method call, it doesn't matter where it's going to, we know this is going to be okay in the context of this rule. So hence, the first two lines are just saying, am I in text message queue processor? And if I am, I'm going to return an empty array because for the context of this rule, everything is fine. The next thing is we now need to know the type of the variable that we are calling our method on. So this is what this line type equals scope get type. So again, PHP Stan provides us this information through its scope class. So if we look at some code, remember that this .sender is the variable, and then notifier player is the name, and then we pass some arguments to it. So what we're interested in is what is the type of $this sender? What is the type of var? So in this example code, we've got person notifier, and we've got in the method notify player, we've got $this sender send message. So in the context of this class, $this sender is of type text message sender, and this is the cleverness that PHP Stan offers us through the scope object. We can ask it questions, and it says, I know that in the concept in this example here that $this sender is of type text message sender. So type will be whatever type the var is, and then the next step is we say, get me any classes that type could be, because type could be anything. It could be a string, it could be an int, or maybe it is a class. And you might say, well, okay, if it is a class, how is it we can have multiple classes? Well, if we looked at this code here in person notifier, we can see in this context, $this sender could be a text message sender or a WhatsApp sender. In reality, I probably wouldn't do things like this. It sounds like they have a common interface, but this is just to show you that there are times when you could have something that could be two or more possible classes. So what happens here is we're going to iterate over all of the classes, and if type doesn't refer to a class, then this get reference classes will just be empty. And then what we're doing is, if we're saying our target class is text message sender, then we know we violated the rule. We know we cannot call text message sender from here. So we're going to return just a single violation using PHP Stan's error builder, where we pass in the message saying you can't call text message sender from here. And remember, at the start of this rule, we said if we are in text message queue processor, we exit because we know that's okay to call text message sender. So if we've got to the bottom, to the lower part of this rule, then we must be in our generic code and we are calling text message sender. So we'll just kind of have a look there. Hopefully that kind of makes sense in terms of what's going on. And then finally, if we get through to the end of this, we just return an empty array because we are not doing anything that violates what this rule is trying to enforce. So what I'll do is I'll show you the kind of code with some comments in, and maybe just take a few moments to kind of digest that. And certainly, if you've got any questions, then pop them in the chat, and we can look at those in a bit. So what we've got here, in not many lines of code, is a custom rule for PHP Stan that will be executed every single time we run PHP Stan, and it will tell us if at any point we have called a method in text message sender from anything that is not a text message queue processor. So we have codified one of our business or architectural requirements in such a way that it means that as long as this static analysis tool is run, any violations will be highlighted to the developer. So I think that's pretty powerful stuff. And once you've written a few of these rules, you can see that it's not a huge amount of code.
Yeah, I think this is really neat, and presumably you can do this with not just function calls, but entire namespaces, right? Because something I've often wished for in development is the ability to say, well, you can only talk to this namespace here from that namespace over there, and I know that if you're trying to get into it from somewhere else, then you're doing it wrong.
Yeah, and actually, what's happened is people have written tools to make this a little easier. So. Just, I suppose, sticking to the example I had at the top, the problem I was trying to solve, the more generalized version I've come up with is, this is actually an idea that's in C++. They've got a concept called friend. So what you can do in the example code at the top of the slide is we've got text message sender, and we said its friend is text message queue processor. And that means static analysis will look at this and go, oh, okay, I know I can only call methods within text message sender from the text message queue processor. And what we've done there is, that means you can just use this PHP language extension library that are referenced on this slide. And instead of doing all the stuff I just talked about, you can just add the friend attribute and say, who is the person, who is the class that is allowed to call text message sender. And if you want even other kinds of architectural things like what you're talking about, you've got one section of code that can call another section of code, or cannot call another section of code, then there are quite a few tools that do this now in PHP. There's one called PHP AT, PHP Architecture Tester. So you can with relative ease define kind of rules. For example, you could say my controllers can only talk to services and they can't talk to repositories. Or if you kind of have like the module example you were talking about, you say module A cannot talk to module B. Maybe if you're doing kind of layered architectures, again, you can enforce the correct direction of communication between the layers. So, and the great thing about these static analysis tools is you just write the architectural constraints once, and that is then just enforced every time static analysis runs over your code.
Yeah, so you mentioned there that this concept of friends exists in C++ already. So do you think that the static analysis tools are really just kind of outriders for actual, compiled language development? Because this is all stuff that your compiler can do too, right? Yes.
So if your compiler has these, if your compiled language has these constructs like friend, then essentially what we're doing here, static analysis, is quite similar to a compilation stage in another language. I suppose the benefits of static analysis is, to my knowledge, the only language that has friend is C++, but might well be others. So if you were using, I don't know, Java, and it's been a decade since I've used Java, but at the time it didn't have the concept of friend, you could do similar to what we've done with PHP, but in Java world, and kind of implement, the friend functionality. So static analysis offers, in many respects, more than just compilation. And even if you've got compiled language, there's still benefits with adding static analysis on top of it.
Yeah, sure. So you clearly spend a lot of time working with this stuff. How do you think working with advanced static analysis, concepts like this, has changed the way that you yourself program?
So it's changed quite a few things. So a few of the examples we've seen in some of the earlier slides. What I'm always asking is, when I write code, is there a way I can write it in such that whatever assumptions I had at the time, if they turn out to be changed, the static analysis tool will warn future developers or me in the future about whatever assumption I had. So, for example, that cost calculator function, the assumption at the time was there was only adults and children. And because I have got rid of my default clause from either the match statement or the switch statement, it would mean that if in the future some other person decided, oh, we're not just going to deal with adult and children, and they updated their bit of code, if their bit of code could call the cost calculator, a static analysis tool would say, hang on a minute, you need to update this code as well to cope with student sake. So I'm always thinking about how I can write my code in such a way that that it kind of protects the future me or other developers. And similarly, I also add in dot blocks where you need to extend where PHP's type system isn't rich enough. So, for example, anything to do with generics, I add that in because, again, it just helps me out. It helps me make fewer mistakes. And sometimes even IDEs can understand bits of these. So the auto-suggest is then context-specific to what I'm doing. So it helps me write code a little quicker. And what I've really started doing a lot more of recently are these custom rules. So just to enforce rules that we have on projects. And also the great thing about a machine telling a developer they've made a mistake is the developer goes, okay, I'll go and fix it. Sometimes when a human does it in code for you, there's a bit more tension. So the idea would be if you could kind of codify in custom rules as much as possible, just because it means it never gets to the code review stage because the static analysis tools pointing things out. Really, I see these as aids to making the code clearer and making fewer mistakes. So I think this is really, really powerful stuff.
Yeah, it is. Thank you very much, Dave. I think that's pretty much all we've got here, isn't it? So I think it might be time for some Q&A. You can see there's a few questions already in the chat.
Yeah, Q&A is officially open, everyone. Thank you both for such a nice discussion. I think it kind of continues here. There's one person, I'm just going to read the first one. Felix is asking, is there a chance that this specific issue might not be a problem in another language that perhaps is more strict, such as Swift?
I think that refers to when we're talking about specifically using it to enforce your types within PHP. Obviously, PHP being weakly typed if you want it to be.
Yeah, I think certainly other languages are stricter about these things. So what would be happening is instead of catching them in static analysis, it would be caught by that language's compilation phase. So potentially the match and the enum example, there are definitely some languages which the compiler would show that particular error. I think Java does that now, but it's been a while since I've looked at it. So there are some examples where the compilation stage of a language would catch a lot of these things, but the benefit of a language like PHP is you don't need that compilation stage. So even if your compilation stage get it down to like 5 or 10 seconds, that is still adding a delay into you're making a change. In PHP, you can make a change, you can refresh your browser, rerun the command, and you see that immediately. There is no delay in that. So that's why languages like PHP are still, I think, really good for getting things done quickly. But you can then add in the static analysis stage to kind of simulate what other languages have a compilation. And yeah, you're right. Some of these things will be caught by those languages compilers.
Yeah. Sadly, we haven't figured out how to transpile our PHP into Swift yet. I think there's probably also some, like Rust, for example, I know allows you to specify ranges for parameters in a way that pretty much no other languages do, right? And this is the similar way of enforcing ranges, which probably you'd have to be doing it in Rust if you wanted that. So if you want to be able to put ranges into PHP or Java or TypeScript, whatever, then this would be the way to do it.
All right, thank you. Thank you both for answering this. I think someone also commented in the chat that sometimes using static analysis in a strongly typed language, like Dave said, would be like checking the language rather than the code.
Yeah, I think when you're talking about types specifically, you're talking about differentiating kind of between PHP 5 and PHP 8 even. But I think there's a lot of use cases where you're kind of stuck with PHP 5. And so if you want to do PHP 5 better, for example, then this is a way that you could do that.
All right. Another question, I guess, unrelated is it easy to add tools like PHP Stan to legacy projects?
Yes, and no. If you add a tool like PHP Stan to a legacy project, the initial time you run it, and it probably doesn't matter how good the code is, it will find hundreds, if not thousands, of issues. And what you won't be able to do is you won't be able to fix all of those at once. So you've got a couple of ways. The PHP Stan has got a couple of ways to address legacy. One way you can do it is it has a number of levels going from quite permissive to very strict. And what some people do is they say, well, let's start off on level 1 and we'll fix all of those issues and we'll keep coding. And then once you've fixed all the level 1 issues, you increment it to level 2 and you'll fix those as you're going along and so on until eventually you get to quite a high level. So that's one approach. And the other approach you can take is you can create a baseline. So you analyze your code. And if I was doing this on PHP Stan, I'd probably run it at about up to level 4 and just look at all the issues it finds there, because generally those ones are things that you probably really should fix. And then after that, I would then run it probably not at 9, which is quite strict level, but maybe like 5, 6, 7, or 8, depending on how much type information you've got in your code. The more type information, the higher I'd run it, the stricter I'd run it. But you run it and it takes a snapshot of all of the issues and puts them in a baseline. And then when you run it again, it will only show you issues that are created since the baseline. And that means you can still have quite strict analysis, but it stops you adding any future issues in. And then what you'd also want to do is every so often try and find something in the baseline and reduce those issues. So that's how you kind of do it with PHP Stan.
Yeah, and this is something that Codacy does really well, to plug us a little bit, that you don't need to create a baseline, you just load up your project and we'll tell you how many issues there are. But then when you're actually making new code, you can set up gates to say you can't actually introduce any more issues than there are, and that naturally, with a very strict policy of like 0 new issues, when people touch code, they tend to fix a few here and a few there, and over time it gets better and better. We applied ESLint to one of our legacy projects a while ago, even like a legacy one, which is an old version of our website that had, just a few endpoints that are still in use. And that still found 3,500 issues, mostly to do with code style. But people have taken it upon themselves to go and beaver away at that and just go, okay, well, it should be single quotes, not double quotes. So we'll just do a search and replace all. And then that makes it down to 2,500. And then they do a bit more development. And here's a critical security issue. Well, I'm in this file anyway, so I'll resolve that and so on. So a combination of, like Dave says, diligence in not introducing new issues and periodic sweeps through to just go and make things generally better helps this stuff.
All right. Maybe as a follow-up question, someone is actually asking, what role does Codacy play in this? For example, Martin says they do a lot of Scala dev development. So how could we catch more static code issues earlier with Codacy? How does that work?
Yeah, sure. So, I mean, we run Scala Meta Pro, and we do it for you. So add your repo into add your GitHub or whatever repo into Codacy, and every time you do a commit, then you set it up to say these are the linters that we want. Every time you do a PR or a commit, then we will scan it and say, here are the issues you've introduced. Again, using these gates, you can say, I don't want any new gates introduced or any issues introduced, or say you can't introduce more than one major security issue or whatever, and you can change all of those boxes. So that would definitely catch those issues. We also have an IDE extension now, so if you're using VS Code, then we will pull those PR results. Every time you open a PR, we'll pull those issues right into your IDE, and the next version of it is going to show you all of the outstanding static analysis issues within your repository as well within the IDE, so you can browse it then. So again, you have that while I'm here sort of effect of, I'll just tick those off while I'm here.
Yeah, great. Hope we answered your question. There's also, right now, someone just asked if there's an extension for other IDEs.
There will be an IntelliJ one sometime in Q1. We targeted VS Code first because it's free. It's got 50% total market share of people using IDEs. So in order to bring people the most best stuff the fastest, then we went for VS Code. So doing a couple of versions on there to prove out what we really need, and then bring all of that to IntelliJ early next year.
Exciting. There's one more question here that I think is relevant for both our speakers, and maybe Dave, I know you're keen on static code analysis, and Martin is asking, how essential is integrating static code analysis into the CI/CD process?
Oh, incredibly. It has to be there just to protect from people like accidentally not running it on their own machines before pushing their code up. So yeah, we have it. It runs in all of our projects. It's just part of CI, and you can't get through CI unless you haven't introduced any new errors yet. You cannot get it past CI.
Yeah, and again, in Codacy land, we tend to view the PR as being the place where we do that rather than CI/CD. So you don't have to wait for the build to fail, because there's plenty of languages, particularly mobile languages, where your build could take half an hour. Better for it to just die horribly within 5 minutes of us scanning the PR and letting you know, so that you can revise it again and then re-trigger the build.
Right, so very is correct, like Martin said. One last one. Everyone, if you have any last questions, you are free to ask us. We have room for maybe one or two more. For now, we have Dave, for you. What tips do you have to keep the false positive rates low?
So in the context of PHP, there's lots of things you can do in PHP which are difficult for static analyzers to reason about. And also those things tend to be more difficult for humans to reason about as well. So examples would be if you've got variables, $, something, that your static analyzer probably won't be able to kind of work out what's going on there. But 9 times out of 10, nor will the developer correctly know it either. So what you really need to do to keep false positive rates low is you need to use type information wherever you can, either in type declarations where the language supports it, and in the case of, say, generics, where you need to give the dot blocks with the additional type information in there. The more type information that the static analyzer has, the more accurate its analysis will be. You need to be careful around all the boundaries of the system. So whatever is coming in, if you're making assumptions about that data, then at your boundary to your system, you need to validate that those assumptions are true, because static analysis will be based on what you tell it is happening with all that data. And I think a lot of it is just writing simple code and not trying to do anything too fancy, because some of the fancy things are very hard for static analyzers to reason about. I don't know if Kendrick, you've got any other thoughts on that?
I mean, again, from a codacy perspective, then actually we try very hard with our big customers to make sure their rules are configured well in the first place, because linters can check for a lot of things, and there will be some which are just not appropriate for your context, so there might be some like naming convention ones that you're forced to disadhere to because you're using a third-party library that requires you to adhere to their naming conventions and something like that. So you're going to want to turn those rules off. For us, it's about working with you to figure out what your tolerance for false positives is, cut out as many as we can, and then with our organization level config tools, let you apply that to all of to multiple repos at the same time to try and make it a to make it so that when we flag something up that we're getting it right.
Great, thank you. There's actually another question here in the chat, and it's about Codacy too. Is there a way to automatically add new repos to be covered by Codacy if there's a new added to GitHub?
Yeah, I was just typing out an answer to that. Wash check. I've probably mangled the pronunciation of that, but thank you. I'm not sure off the top of my head, I'm afraid. If you check our API docs, there is probably a way to push, like for you to push a new repo into Codacy to be scanned through our API. And so if you have some set of actions like a GitHub action like on start, then you can punch that through to us that way, I think. But also you're very welcome to, within Codacy, then go and chat to our support agents through Intercom, who can answer that question probably in better detail than I can.
Yeah, that's a great tip. If you go into our in-app chat, there's going to be someone who from a support team who can definitely help you out. But thank you for your interest and for your questions. If there's no more questions in the Q&A, I just would like to say thank you both to our speakers and our experts, Dave and Kendrick, for such an interesting discussion today. And thank you all in the audience for tuning in and actually sending chills down our spines in the chat. In the spirit of Halloween, we really enjoyed reading your one-sentence coding horror stories. And as promised, your efforts to scare developers to their core will be rewarded with the Codacy swag kit. I think you deserve it. So I'll be in touch with you. But yeah, wishing everyone a happy Halloween. And yeah, here you can get in touch with Dave through some of his GitHub links. And there's a couple last second entries into the contest. I mean, great. Try not to scare your fellow developers too much tonight, but do enjoy Halloween. And we hope to see you next time in our next webinar. Stay tuned to our Twitter and LinkedIn. We always announce it there. But yeah, thank you so much for coming, Dave and Kendrick, and see you next time.
Thank you very much, Dave.
Yeah, thank you for having me.
Bye, everyone.